abilities, so it's fun to play the game and not just a showcase of abilities and how to kill each other's unit. Yeah, we're going to have the passive abilities, some random events that are going to spawn in the map. After that, we are going to release the first alpha so anybody can play with it. The difference with MAD, like plain MAD and this version, is that I'm using a backend, so every time you send a transaction, instead of waiting for the transaction to be included in a block and it's executed so you read that value, I'm predicting the result of that transaction and broadcasting it to both clients. So that's why it's smooth on both screens, the player sending a transaction and the player that is just reading the current state. There are some trade-offs. You need to trust the server that is going to broadcast all the transaction and is going to broadcast the current mempool status to each of the clients. But that's one trade-off that we found, that it was fine for our use case to reduce latency and make the game more smooth. So yeah, that's the current state of the Eternal Legends. The backend is Garnet, and we are planning to open source it maybe next week or in 2 weeks, because right now it's a lot of spaghetti code that works fine for our use case, but we want to make something more generic. So in 1 or 2 weeks, we are going to open source all this mempool, like optimistic rendering stuff, and after that anybody can play with that. It's going to be fully compatible with MAD V2 contracts, so yeah, I hope that you guys like it, and we are going to keep working on this game as a proof of concept for our backend. So I was working for the hackathon version, and after that 2 of my friends that really likes blockchain and gaming starting to work with me. So I'm mostly working on the backend stuff, like everything that is being displayed here is being processed by the backend. So I'm working on the crypto stuff and making sure that the WebSocket is sending the correct information to the client. And my 2 friends are working on just the client implementation. They are full focus on that. They are using like assets from the game maker game engine, so they are trying to make a really quick but something pleased to see. So it's appealing for someone, not just the first version that was a CLI client. So both of them are working on the client and I'm working on the server. Yeah, and I just leave there the link if you want to test it out. There are going to be a lot of bugs, but you can feel the game and try it out. It's going to be alive for the rest of the day. Tomorrow I'm going to reset all the blockchain status.
I guess I have a small question. So you mentioned obviously this optimistic rendering. I think that's really cool, because that's obviously something that traditional games have. How was your experience building that? Like, was it difficult? And is that something that you think could be open sourced, like for others?
Yeah, my idea is to open source. Right now, it's like you need to write the code twice. It's the same as when you are doing optimistic rendering with MAD, that you need to write the Solidity logic replicated on the React client where you can make the prediction. Right now, I'm rewriting the Solidity contract in Go because the backend is written in Go. You just need to write your prediction for every action that the Solidity contract is doing. My plan in the future is to try to make a transpiler from Solidity to Golang and try to adapt that code, so you just need to write it once. But right now it's the same that when you create a prediction on React, you need to transpile manually the code from Solidity to React in the case of MAD or Golang in my case.
Hell yeah. Well, if you ever do the Solidity transpiler, let me know. That'd be pretty sick.
Yeah, I was looking at open source solution and they are kind of limited, but maybe it will work for our case. Okay, thank you for having me.
So we're gonna do a 2-person demo. Maddalena is going to present some stuff, and I'm going to talk about it. So what we're doing is we're generating all of the metadata in JSON format using LLMs. And then we're feeding that into a system that takes essentially that setting and all of the things that are generated, the character, and place queues and role plays it. And so the actual game is fully on chain, except for that, using Mud. And then we're also going to show you some of the things that we're adding to that. We're basically taking that forward in a few different ways. Is it working for you now, Roger?
Yes, now it's okay.
Wonderful. Okay, I'll hand the baton to you.
Okay, so this here, all the maps here are imported from another game that I'm developing on Ethereum mainnet. It's called Endless Crawler. It's a dungeon crawler generator that can be expanded indefinitely, and I'm building an SDK, and I'm going to open source the SDK, the contracts, everything. So this is the first time I'm actually using this infrastructure for another game, because that's exactly the idea, that this world can be shared with other games to build any kind of game. So all the maps here are imported from Ethereum. We have some different kind of terrains that can be used by in any way the game developer wants. And we have some entities on each chamber, so we are using these entities here to represent as NPCs that we create using OpenAI. You can see that we have the location here on the right side with some preview image also generated on OpenAI. And when it gets close to an NPC, we have also the name of the NPC, description, all the characteristics of the NPC are generated based on the properties of the chamber. And we can chat with them using some designs that Supermancer wrote that talks to OpenAI. So we tell GPT just how this NPC must behave, its characteristics, and everything, and then it starts conversation with us. This character here, it's she's lost and she needs some help finding her way. And based on the conversations, the NPCs make a score of how much are you helping them on their quest, and or how much they are helping us. And based on that, we have these conversations, and everything is stored also on chain. And here we can see I still didn't complete my task. I'm score 10. So all the metadata generated by the OpenAI is stored on chain, and also the conversations. And this can integrate with the other project we are building. So this is hyperspace. DC Professor can speak better about this. But I'm just displaying here that we are sharing the metadata also using our own CRDT sync server. So we are opening all this data also here on this other system running on another server. So Hisipromancer, if you want to talk about that.
Yes, hello, sorry, I'm back and I can now see the screen share. Amazing. Okay, so Endless Quest is the game client. This is Hyperspace, which is something that we're building related to the Hyperbox protocol. But TLDR, it's a local first state synchronizing self-sovereign protocol, and this is a metaverse built in it. So everything that's happening in this is essentially stored on your local machine and synchronizes to everyone else who's using it. Now, the reason we're interested in that, of course, is that it's got similar properties to blockchain, but it lets us do things that are currently hard on blockchains. So what we've done is connect those two things together. So when the AI essentially generates metadata, it's getting stored in an associated hyperbox or hyperspace room, which has the same map, and so on. Now, what's cool is we can talk to the same AI from both sides. So this is composable. And we're adding some some cool stuff soon, like the ability for you to run the AI locally and synchronize the results into the on-chain game. So it would be fully self-sovereign with no platform AI involved, as well as a few other things along those lines. So we'll also make the image generation fully open as well, using stable diffusion and so on. So the and for anyone who still can't see, the other thing that fixed the screen for me, by the way, was just hitting disconnect quietly and then coming back into the room. That was what finally fixed it. So yeah, so what you're seeing here is essentially the same data shared between both places. And yeah, so we're going to basically add like asset generation AI and metadata generation AI that you can run sovereignly, and do a bunch of other stuff like persistent world agent interactions. So as players kind of come into a room and interact with an AI, it will start to remember what's happened in the past, both your playthrough as well as cross-player playthroughs, and then that will shape how it role plays. So I'll there's kind of a lot here, and I don't want to like take the stage for too long. So what I might do is open it to questions. If anyone wants to ask something about what we're doing here or what it means. But TLDR, it's we want to basically put this out so you can all use these kinds of systems in your on-chain games. Yeah, proof of Jake. So the link between the games is that, so basically Hyperbox is state synchronizing, which means that there's really not very much difference between a server or a client. Everything is just a peer and it synchronizes state to everything else. So what we're doing is essentially the game client is synchronizing state into the Hyperbox. So the stuff that's not on chain. And that means that then you can see all of that state as a user as well. That's basically what's happening. So any changes that essentially it's almost like integrating them, right? Like any changes that happen in the game state can be shared into the Hyperbox, but we can display that in a spatial interface, metaverse paradigm, which means not just superficially showing the data, but also being able to interact with it on similar terms. I hope that answers your question.
All right. So during the hackathon, I made the Netherscape, an RPG demo, and for waifus. So after the hackathon, I have some thoughts about space battle and stuff. So I made this small demo. I think it has potential to be built further. So let me just show you what it is. So okay, maybe before the demo, let's talk about it a little bit. So basically, it's like a rocket and hold on, it's rocket and the booster kind of game. So in the space, it's frictionless. So in the game, it's frictionless. It's a frictionless space, and then you catapult your fleet or your squad, composed of mech units to space. So this way, it travels like infinitely, keeping the velocity. So you need to use acceleration booster. You have a limit of amount of the booster you can use. So and then you can use it to change the direction of your velocity. You can deaccelerate to stop it, or you can accelerate to other directions. So the goal is to reach a destination, and then keep the a same relative velocity or zero relative velocity with your target, so that you can attack. Hold on. So okay, so let me show you what it is, and then maybe you guys can ask questions later. Okay, can everybody see the screen? Because it's there's a okay. So this is the first player. I'm going to spawn a player on this planet, and then I'm gonna spawn a squad on for this player on this planet. And then for the second player, I'm gonna do the same. Spawn a player and spawn a squad. So what I can do right now is for this player A, so he has a squad. I can catapult it to a planet. So you can see this. This is vector of velocity auto calculated, right? So I can confirm it, and then you can see the squad is being sent. It's traveling through block. And then I can, for this second player, I can try to intercept his squad. You can see this is the vector calculated to intercept it. So you can see they are closing in terms of distance x and distance y. So there's a client side function which will call once the dx and dy being within certain range. So when they are getting smaller and smaller, it will call a contract function called lock on. Once you can see it coming, yeah. So once it's lock on, the two squads coming into onto with the same velocity and the same position. So they are going together. So because it's lock-on. So during the lock-on, the two squads has no difference in terms of velocity and distance. So this can be a battle happening. Right, so squad A can attack squad B and vice versa. So what's happening here? So that's end of the demo, or whatever. What's happening there is I only have the Notion file here. So we see the lock-on. It requires the position velocity needs to be within certain range, and then a contract gonna be called. A contract function gonna be called and calculate the amount of boosters it's gonna use. So yeah. So a lot of things happen on the client side, like if I need to. So for example, you see the vector of velocity change when I try to intercept a squad, right? So this is a client-side plugin I use for myself. So it calculates the acceleration direction I need to use so that my squad can intercept the enemy squad. And then there's another plugin I use. I listen to the distance between these two squads, and then I do a lock on. So that's also not automatically done, but yeah, it's automatically done on the client side. So what happens is I think we can enable like space dogfight. For example, like if my squad is being locked down, I can use another client side plugin trying to evade this kind of attack. So I can accelerate my squad to the opposite direction so that he can never catch me. So then the fight's gonna go on, right? So I can listen to the transaction pool. If somebody do something in the transaction, I can do it, send the transaction in the same block. So I think it's pretty interesting, right? So this physics, it's kind of physics. You calculate the kinetic energy, and it has to be within certain range. So yeah. So I think that's all. My time is running up. So if you are interested, want to build together, so send me a direct message, and let's think about some like pretty cool mechanism we can build together. So I'm probably gonna playtest it in the coming month. There can be like StarCraft style or so anything. So yeah, so let me know what you think, and yeah, that's all.
Yeah, I have a clarifying question. So the thing we saw on the client, the position of the fleets, that's all lazy computation, right? Like that's just the client computing where the fleet basically would be based on the like direction and velocity. Is that right?
Yeah, so I think you're right. So only two, only initial position and velocity is stored on blockchain. So what happens is, if you change your velocity, it's gonna calculate everything, right? Recalculate everything. And the second is, if you want to target an enemy squad or whatever, it's gonna calculate the position based on its velocity and the position. So there will be a starting block being set on blockchain. So yeah, essentially you're right. So I think that's pretty interesting. We don't need to run a tick or whatever, because everything is happening on chain. Yeah.
Very cool. And then, so in order to lock on to an enemy fleet, you basically have to be like close enough, right?
So
which means
you have to
execute your transaction basically in a block where your fleet, based on your velocity vector and their velocity vector, would be in a close enough position, right? So you have to, in the end, it's about getting your transaction in at a certain block where the position matches up. Right?
So that's only one condition. The second condition is the velocity. You cannot have a very different relative velocity. What I mean is,
got it.
So so it's kind of easy way out, because I don't want the contract to calculate the velocity. So what happened is, it's gonna calculate how much boosters you can use to adjust your velocity. So, and then I would just round it up. Yeah. So if, for example, if you have 5 boosters, it's gonna calculate how many relative velocity you can go to. Can you adjust it within the 5 boosters? So then it's gonna subtract the booster you have. So nothing. Yeah, so nothing fancy over there. But it's rockets. You have to have rocket boosters to. It's not like Tony Stark. He's invents infinite energy, right? So yeah.
Very cool. Very cool.
Okay. All right. Thank you, guys.